All right, good morning, Calculus 1 students. So we are looking at test bank 2, and we are going through problem number 2A here. Find the extreme values of x to the 4/5, x minus 4 squared, and we'll go ahead and figure that out. Okay, so we've got the function sitting here. We have to figure out the critical values, which suggests we have to take a derivative. So let's go ahead and do that. So y prime equals, and what I'm going to do is say x to the 4/5, and we have to do derivative of the first times the second plus the first x to the 4/5 times the derivative, oh, this is squared, okay, times the derivative of the second, brackets around it, tick for the derivative, and we're going to set this thing equal to 0. That's the whole point, right? Take the first derivative, set it equal to 0, solve for x. That's what we're going to do. So let's go ahead and start taking derivatives. So this is going to be 4/5 x to the negative 1/5, right, minus 1, times x minus 4 squared, plus x to the 4/5 times 2 x minus 4. And this will be to the 1 now. Okay, we're not going to write it because it'll look like a derivative. And set this guy equal to 0. Solve this however you would wish to solve it, okay? I don't like negative exponents, although I'm going to remember it's there, but I'm going to multiply everybody by 5 x to the 1/5 power. Okay, let's see what happens. So the 5 is going to cancel with that 1/5, so we get 4. This x to the 1/5, x to the negative 1/5 is just going to go away, so we're just going to end up with x minus 4 squared plus 5 times 2 is 10. X to the 1/5 times x to the 4/5 is just going to be x to the 5/5. We're just going to call that x times x minus 4, set it equal to 0. We're going to go ahead and solve. So what I first noticed is that instead of dealing with a bunch of quadratic formulas, there's an x minus 4 that I could pull out of both of those terms. Okay, if you didn't see that, that's okay. But what we're going to have left is we have a 4x minus 4. One of them is over here now, plus 10x, and this whole thing is equal to 0. So we have x minus 4. Let's put that off to the side. Then we have our 4x, right, minus 16 plus 10x equals to 0. And then we have to go ahead and solve this little piece here. So x minus 4, and then we have 4x plus 10x is 14x minus 16 equals 0. So either x minus 4 equals 0, so x will be 4, or 14x minus 16 equals 0. We'll go ahead and say x is equal to 16/14, which is 2 times 8 over 2 times 7. So x will be 8/7. Okay, but don't answer yet. So far we have a list. We have x equals 4 is a critical point, x equals 8/7 is a critical point. And then remember I said I don't really want the negative exponent to interfere with everything, but we had to remember that it was there. When x is equal to 0, this derivative doesn't exist. So that's also a critical point. So the 3 points that we actually have are x is equal to 0, x is equal to 4, and x is equal to 8/7. Those are the critical points that we actually have to deal with. If we really wanted to, I guess we could go back in and plug in values. When x was 0, this is going to be 0, 0. Okay, so I guess the y values is going to be 0, 0. Y value, if x equals 4 would be 0. And then we have to type in 8/7. And since I don't have a calculator real handy, I would say, okay, that's going to be 8/7 raised to the 4/5 times 8/7 minus 4 squared. And that would be the value for y that we would want to put in for that. Okay, so if they want the actual points, I suspect they do, we could say 0, 0, 4, 0, and then 8/7, and whatever this mess happens to be. Okay, and again, I don't have my calculator handy, so I will let you guys go ahead and figure out the 2 decimal approximation for this mess. Okay, so that's what we've got for all of that. We will see you in the next video. Thank you very much for watching. I hope studying is going well. So good luck, everybody. Thanks.